Welcome to the Unsolved Problems in SRE panel. I have an esteemed panel of folks here to join us. Sandhya Ramu from LinkedIn, Narayan Desai from Google, Laura Nolan from Slack, Xiao Li from JP Morgan Chase, and Niall Murphy from Reliability. And welcome everybody. So before the session here, we had gone through and tried to identify some topics for discussion. The first one that I want to raise for the panel is models of SRE work. How best can SREs engage with their colleagues and get their work done? Anybody can take that one. Or let's talk about varieties of SRE work that you've seen.
Okay, I'll jump in. So I think we've seen, so SRE kind of, it originated in Google, and there the model of SRE was very much, you have a service, and that service has some devs, and that service has a separate SRE team. So you have the sort of the separated ownership model, and you have your SREs that are very focused on doing production work, hands-on work, but also engineering work with the services. And so the whole idea is that you have this sort of, two teams with slightly different interests that work together. Then with the rise of cloud, primarily, we started to get to see more of a consulting model. So you have teams of SREs whose main goal is to sort of act as consultants to other teams and to help them to, I guess, get their service more production ready and solve some problems that they have, but you don't have that same kind of sustained ownership model. So the challenge that I think that we have with the consulting model is that it's very easy to get a little bit sort of shallow and checkboxy and sort of, have very much one size fits all solutions. I think we could probably think of a variety of things. I'm not going to name SLOs in particular, but I think that's an example. But then the problem with the other model is that it's only maybe more suitable for large organizations or where there's a lot of resources for SREs for hiring them and for headcount. So I think that's one of the sort of the tensions that we have with the SRE model in the industry at the moment.
All right.
To pick up on that, I think there are a lot of aspects of the sort of traditional SRE model that are really expensive fundamentally, right? You need to get engineers that can do both on-call and engineering work. You need to have enough work for them to do. That sort of implies that you have a service of a particular size or a team of a particular size. A lot of the ideas about sustainability are expensive to maintain. And so, I think that there is a real important question for scale down that is still open. I know that there are a variety of folks that are working on it, but it's really hard to see how some of the traditional practices work in really small environments. And so I think that probably what that means is that we'll need to develop analogous processes that just work differently.
Okay, now?
Yeah, so I think the first thing I'd say is that a lot of the stuff that Laura described and a lot of the stuff that's in the SRE books and so on, I think my current view is coming closer to regarding a bunch of that as being essentially kind of organizational fluff or cover or inessentials, organizational inessentials with respect to the underlying job, which is making something more reliable. If that's true, I think the unsolved problem in SRE is that we do not know the extent to which the practices and organizational patterns and so on and so forth, which have been developed, contribute positively towards making things more reliable, or to what extent they don't. And even though fairly obviously a number of us in this meeting have quite a number of air miles on the existing model and would have reason to refer back to our experience and say, oh yes, this is definitely a moment when the SRE model worked well to address problem X. Like, I'm not actually sure that's true. But anyway.
Okay. Xiao?
Yeah, and one more model that I saw is some SRE team will function as a group to think about production readiness and build validation tools to basically act as a building the toll gate for the product. And that is in certain groups that works really well, because that kind of build enforcement for the application development team to think about the non-functional requirement before they can go into production, and remove the human acting as a gatekeeper in the between.
Sandhya?
To chime in about another model is, doesn't matter whether it is large companies like Microsoft, Facebook, Google, or just small businesses that are starting off. I think data is very key for functioning as a business. And I think there is a new breed of engineers / SREs required to be ahead of the curve to figure out how do we do data reliability. Like it could be data freshness, it could be just data health, it could be the data, like how it changes over a period of time. I think there is a new domain / like a new path that needs to be paved from the traditional model of how SREs functioned when it was service-based reliability versus database reliability.
Any thoughts from other folks on the panel about a different set of skills or adaptations for data focus?
I think it's increasingly important in the machine learning world, of course. And I suspect that, as many folks here will agree, request response architecture paradigms are widely understood. And it might seem that other kind of paradigms, maybe pipelines or data reliability, et cetera, are not as well understood. I think the answer to that is slightly subtle, and I think it's well understood in some narrow contexts, but I'm not sure that that information or those best practices or those skills are really making their way out of those narrow contexts into other places. And I think that in some sense, even though the job of SREcon is to help us kind of talk to each other, is to help the profession talk to itself, I'm not sure we're saying all of the things that we need to hear. So all of which is a roundabout way of saying, like, I agree with you, it's not commonly understood how to effectively address these challenges. And most people are just kind of reasoning from first principles when they're taking on these challenges. That doesn't mean that reasoning from first principles is bad. In fact, actually it's good sometimes, but it is potentially pretty inefficient to have loads of bits of the community reasoning from first principles on the same thing time after time. So I think an unsolved problem in SRE is how we get this information from team to team, and even inside the same organization, by the way, like never mind between company to company, but that's very much a separate route.
All right. Brian?
So the way that I think about some of this is the underlying complexity of the service, right? So if you think about RPC serving systems, the services tend to have predictable outcomes, where at the other end of the spectrum for ML services, you don't know what's supposed to happen, right? And so it can be really hard to do QA, and that's been a really substantial focus of engineering work and a variety of these things. I'll point out that this is not actually true in any really deep sense that RPC serving systems are solved, right? What I think has been the thing that we have described as success is that we have narrow kinds of RPC systems that have sort of well understood results, where we can have a lot of confidence that they're functioning properly. But some RPC services are extraordinarily complicated, right? If you would imagine a service that takes code that you upload and run it, that RPC service is going to be very hard to understand, how well it's working and if it's breaking and all that sort of stuff. And so I think I think that this is really one of the things that we need to struggle with here a little bit until we come up with some satisfying solutions. Like we need to be able to get our arms around what we expect to be happening and to start to describe our systems in terms of invariance that we can use to tell if things seem to be working or not. And that is easier in certain cases, but I think as time goes on, we'll get better. You know, if you think about the approach that ML training systems usually use to do correctness checks, it's testing on subsets and things like that. Like they're basically building an invariant that they can use to infer if their system's working properly. And we need to get more organized about how we think about things, because there are probably common threads that run through all of these different kinds of problems.
Niall.
Yeah, I was just going to say, reflecting both on what Narayana said and on some of the previous comments as well, one of the things that I like about the emerging safety 2 movement, understanding incidents appropriate kind of post-incident response and so on and so forth. There are a number of things I don't like, but one of the things I like is that they typically observe that every system is a socio-technical system. It has some degree of human behavior required to understand it and some degree of technical behavior required. And I think what I have been reflecting on over the past while is that a lot of the definitions of how we manage systems today, or what the best practices are, etc., are effectively socially defined. They are not technically defined. Now, okay, that's an exaggeration. Some things we know how to do. We, I suppose, reason from first principles in certain contexts and so on and so forth. But just what Narayan was saying there about, actually, if you did have an RPC service, the job of which was to suck up a random binary and then run that binary, like what is the request response RPC service like really providing you as a conceptual framework for understanding anything about the operation of such a service? And the answer is not very much. But like it's a very thin layer of conceptual framework. But I think sometimes we socially define that if we have a request response system, then we know what the behavior of the system is and so on and so forth. And actually, I'm not sure that's true.
Harkening back to some of the formal methods sessions that we've had at previous SREcons, I think that, yeah, there's a good case to be made there that formal methods may not apply particularly strongly. Laura?
I was just going to say, I mean, RPC frameworks, I think we're, taking them a little bit lightly. I mean, RPCs are just the interface to a system. I mean, most of the systems, if you look under the hood, there's, all sorts of architectures going on. There's data, there's, possibly pipelines, there's all sorts of things. So RPCs are not necessarily as simple. But I want to echo something that Narayan said. I mean, trying to figure out these invariants. What are properties of your system that should be true? I think we're probably going to talk about, knowledge and how we know what we know later on. But I think this idea that there are certain properties of our systems that we can use to validate them is quite important. And that's one of the things that also comes in from some of the safety culture stuff, sort of figuring out, what are the constraints on your system? What are the hazards? And, what can you do to sort of know if your system is where it should be, right?
Mm-hmm. So let's get Narayan's comment, and then maybe we'll shift over to that question of how do we know what we think we know about our systems.
So in my mind, thinking back on what Lauren and I were just saying, this comes down to, I think, a failure to abstract our systems properly, right? So we have a kind of artisanal understanding of our systems where they're all different. And, this one has this kind of a workload, and that one has that kind of a workload, or maybe we abstract a little bit in terms of the architectures that we have in terms of internal patterns. But I don't think that we've really done enough work in figuring out what makes our systems similar and different, because that's I think really the road to figuring out what are these invariants. And the more general the invariants you can build are, the more powerful they're going to be. right? If you think about, I'll just sort of pull this example out, not to talk about SLOs too much, but if you think about the way that SLOs function, they're a very narrow window of a particular facet of behavior about a service, right? And for that reason, they're relatively weak in terms of your ability to abstract around them. The more that we can step back and build really solid abstractions that we can use to generalize what we're doing, the better off we're going to be.
That sounds an awful lot like an article that appeared in Login magazine a few months ago around SRE as high modernism. I would refer any listeners to that article for maybe some more insights there. It was actually written by Laura. I won't be too coy about it, but it sounds like you're proposing that the better the abstraction, the more abstract the abstraction, the more powerful it is. And I think that article was actually making a counter case for that, against that.
We don't always agree, Laura and I.
Whenever Narayan and I agree, you know that something's probably right. I will say I don't entirely disagree with Narayan here, although I will say that it's all abstractions are leaky and a lot of problems creep in the joints between what you think are two nice solid abstractions and then suddenly, you know, something about the semantics of these systems or some aspect of behavior that's not captured in the SLOs can cause surprises.
Yes, exactly. I think it's the leaky abstractions and where they leak and how they leak that becomes the key in many cases for reliability. So let's talk about another topic area that came up was how we know what we know about our systems, how we monitor them, how we can effectively deal with challenges in knowing about our systems. Narayan, you alluded to it here in your last comment. So thoughts from the panel on understanding our system, I guess, is the most general way of phrasing it. Narayan, you can take that first.
Sure, I'll start with a relatively negative opinion and then everyone can argue with me. I mean, I think that we're unfortunately in the situation where we really don't understand nearly enough about our systems, right? So we have taken this very narrow understanding kind of an approach. And I mean, to our credit, we've made systems that work, and that's great, right? But it's really hard to answer the question why. So one of the things that I've seen a lot recently is comments that valorize the use of the phrase "it depends" among senior engineers. And while we all do that a lot, right, I don't think that's great, right? Like that is a sort of tacit admission that we actually don't deeply understand, you know, why we're doing beyond sort of on an artisanal basis. And I think that's an area where we need to work hard because these systems are getting more and more important, right? So I guess I'll just leave it there.
Anyone care to take issue with Narayan's point?
Oh gosh, yes. So it depends is definitely something I say, Narayan. And I think it is helpful if you could say what it depends on, right? Because, you know, our decision trees are not simple linear decision trees. If that was the case, then, you know, I don't think it will be nearly as difficult to do what we attempt to do, right? I think it is important to understand that there's a lot of complexity in both our systems and also the above the line stuff about how we think about our systems and how we make changes to them and so on and so forth, and how we choose what to invest in. I think, you know, it's not cheating to recognize that there are a lot of factors that go into making particular types of decisions. I think it's important to figure out what it depends on, but I think saying it depends is not the wrong thing.
Sandhya?
Yeah, I think it is true that we have a lot to learn about our systems, but to Narayan and Laura's point, I think we've made a lot of progress, primarily by integrating data science algorithms and things like that to predict some of these things, right? For instance, look, okay, capacity insights was not something that we could easily do say a decade ago. I think we are now able to predict, okay, what are our peaks and troughs, and I think make adjustments in an automated fashion, right? Anomaly detections is also another way of at least understanding, okay, if at all these things are happening, answer the question why. Obviously, it's not foolproof, and the data, what is there in the history is what is used to make these predictions. I think definitely there's room to grow, but I think we've come a long way to use some of these additional things, could be AI, ML, and things like that, to make the life of an SRE a little more predictable and aware of things rather than going completely blind like we were possibly a decade ago.
Do you think that having one black box, an ML system that explains another black box, really gives us explainability?
More than explainability, I think it is like the predictability aspect of it, right? Okay, these were the X behaviors that happened, and based on this, here is the assertion I'm making. I think that's possibly how I approach things, wherein you have a little more understanding based on, or else in the past, it would be much more harder to have that correlation of history and what is coming up in a more scientific manner.
Okay, thanks. Niall.
Well, it's an empirical manner. It's not necessarily a scientific manner. I mean, to echo a little bit about what Kurt is saying here. And don't get me wrong, I'm not quite an epistemological nihilist. In fact, I kind of try and avoid that, although anyway, I'll stop. The difficulty, I think, is that even if we get completely accurate predictions, this does not mean we understand the system. It means that in a giant linear map of knobs and levers and so on, we can have some confidence that when we turn this knob, this thing will happen. Does that mean we understand the mechanism? No. Does that mean we understand that if such and such additional dimension Z gets added, what happens after that? No, like very much not. So to me, it's not an understanding. It's a kind of a black box behavior style thing. We've no inspectability. We've no real sense of the mechanics. Now, I suppose an additional criticism you could apply at this point is you could say, well, Niall, you are clearly a high modernist, as has been said to me before, which is to say that actually this rootless searching for a model for things actually isn't the thing that matters. The thing that matters is when the thing goes bad, you can go ka-thunk and have it go right again. Every other focus is irrelevant. And I think that's one to me of the most unsatisfying things about the organizational position of SRE and the cultural position of SRE, which I would class as an unsolved problem, which is that it's very impatient with theoretical models. It's very impatient with things that don't have a practical application right now. And that might mean I'm a high modernist, but I do think we should reflect on this more.
All right, we've got a bunch of input ideas here. Narayan first.
Yeah, I think that Niall really captured the core of this question, right? We don't really have models that help us to interpret our systems today. And I think that this is a tremendous problem because we have, this sort of ranges from relatively simple situations to really complicated situations. And I would actually step even back one step from models to consider, we don't even have concise terminology, right? And because of that, like, you know, I don't, this would, I think, completely derail the conversation, but we could probably spend the rest of our time trying to decide what reliability is, right? And then we could have another session on another simple word, like what is an outage? And at the end of those times, we wouldn't have a good description of what it is we're talking about. And as long as we don't have that, it's actually really hard to make any progress on anything, right? And you're in some sense stuck with the high modernist approach. The best that you can do is the best that you can do from a really practical perspective. Grab your pipe wrench and whack the system when it breaks. And I find that really unsatisfying because what I really meant by this comment about use of the phrase "it depends" is that it depends is often not followed up with nearly enough information about what it depends on, because that in turn requires having a pretty fine-grained mental model in your head, which we often don't have, right? It's not universally the case, but everybody's got, a very, very partial view of what's going on. And that's, to some extent due to the lack of interpretive models and poor data and lack of time, right? Like all of these things add up in a really complicated way. And the fact that we don't have a scientific approach, I think is really a big issue.
Okay. Laura?
Gosh, it turns out after all that we agreed. No way. I just wanted to follow up on something that Niall said. Niall, you said that empiricism is knowing that if I whack the thing and it will do this, if I turn the knob, it will have this behavior. The problem is in our systems, what happened to my system under certain conditions when I turned that knob yesterday, it might do something quite different tomorrow. Bug is in the code, environmental conditions are different. Everything is kind of connected to everything else, which makes empiricism quite difficult. And I think that, practices such as, chaos testing or and even things like fuzzing and so forth are some attempt to try and get around that sort of the problem of constant change and just like infinite complexity. But I think that we'll probably always be constrained by these problems. My system tomorrow is not what my system was today or yesterday.
Well, and I guess one of the things I've observed is that this concept of even mental models that has been talked about by various people is typically a statically oriented concept. It does not look at the model as something that is constantly moving. If you were to think of a child's mobile, where you push one item and the rest of the whole system moves around in response, that's typically not a feature of most model descriptions as people attempt to convey them verbally or in writing in some fashion. Well, now that we've decided that we know nothing and we can't even describe it, and we don't even have terms to describe it in, I'm a little bit perplexed as to how to continue. So maybe we should shift the conversation slightly. Xiao?
I think I am a little bit more optimistic about how we know about our system. Sure, every system is different. There's a lot of complexity, but I do believe compared to few years ago, the industry standard or the trends really moved a lot already. Just talking about the amount of data that is our system is able to generate to supposedly provide us better visibility, better interpretability to our system. I think the data is there. I think we're just in the process of, now you have the data. Now we need to be able to learn how to interpret the data, how to understand it better, how to apply that to improve the system. Another thing that part that I think a lot of people that I talk with struggling with is from it's slightly easier to understand the technical changes or technical aspect of their system, but connect that to the business value, because ultimately we're all delivering some business value to the client. Understand that, build that bridge is another very much open question with a lot of conversations I have.
Right.
Yeah, I think there are two things. I definitely strongly agree with what Xiao was just saying. We need to actually figure out how to connect the systems that we're building and the work that we're doing to what actually matters to the business. And that's a huge ongoing challenge. And I think one of the areas that I've seen this really play out in an interesting way is the extent to which you define reliability in your own terms versus the customer's terms, right? And this is the thing that we've really struggled with quite a lot over the years. And I think we're getting better at it. And for the record, it may not sound like it, but I'm actually pretty optimistic. I think that we can do a lot better, right? We do have tremendous advantages now compared to where we were, and that means that we can see phenomena at a far finer scale than we ever could before, right? I have friends that work in science in various places, biology and medicine and so forth, and like they would kill for the kind of data that we have, right? So we have huge advantages in lots and lots of ways, and I think what I'm hoping to see over the next 5 to 10 years is a real embrace of partial models, right? Fitting these collections of data that we have in order to understand various phenomena of our services. And I think that we can do it. It's a question of doing a lot of work and doing different kinds of work than we've done before.
Wow.
Yeah, I was just going to say, we could do a lot better is kind of like those most improved profession in software engineering kind of things. Yes, we're the most improved, but that's because we've come from a pretty low base. I think I share, God help me, Narayan's optimism with respect to, we actually have a significant number of advantages when it comes to exploring this space, making conceptual progress, et cetera, et cetera. My fairly deep concern, though, is actually a little bit speaking to Xiao's previous point with respect to delivering business value. Delivering business value is why we're here, but understanding cross-business stuff is how we scale. So by recognizing the patterns in the systems and doing kind of deep conceptual work, we can solve many problems for the business at one go. But the business is also impatient. The business also wants the thing fixed now. And a lot of the teams that I know spend the overwhelming majority of their time just keeping the lights on. So I suppose I'm optimistic that progress can be made, but I don't see a huge amount of attention paid in the profession to making that progress in general.
So I think that does give us a nice segue into another area of discussion, and that is, how do you measure, how do you learn from some of the more qualitative aspects of our socio-technical systems? We can instrument our computers ad infinitum to the limits of our ability to store the data, at least. But the people side of the socio-technical system is much more challenging. Even bringing this panel together, Laura pointed out that some of our fundamental challenges were people-based in terms of scheduling and coordination. And while I don't think that these are specific to SRE, and so we're not really going to talk about these aspects in this panel, there are questions in a socio-technical system when you're trying to get better reliability or the right level of reliability. Would anyone care to talk about that side of the equation?
I can start us off. So something that Niall just said there actually, as you say, segues really well into this. So, Niall just asked, how can we get away from doing so much keeping the lights on work and doing more deep conceptual work? And well, I think there are, a lot of organizational reasons why it's hard to get to the deep conceptual work. I think that there are other factors as well. And one is, is your team in a place to do the deep conceptual work in that they've actually been around long enough with this system to know what the problems are that can benefit from deep conceptual work. I think it's quite rare to be able to, jump into a big complex system on, day one or even, month 6 or so, and necessarily have that sort of understanding of how you can really improve that in a meaningful way. So I think, stability and sort of the time in the system, we're living through these crazy pandemic times, and we're in the midst of this so-called great resignation, and I certainly have seen a lot of people in the industry moving around. So I think partly it may be a sort of a lack of tenure, as well as certain of the other problems. So as for epistemology, I think some of the things that are hardest for us to know about our systems are around the people side. How confident are people? How well do they understand certain parts of the system? How comfortable are they making certain types of changes, or making that sort of that pitch to spend 6 months building a new thing that's going to revolutionize and your system and get rid of all this manual toil and risk. How can we empower people to feel that they can do that and to see those opportunities? And that's a really difficult thing. I've probably talked enough now, so I'll stop.
Anyone else?
Not enough, Laura, not enough. So I hear you say that part of what might be contributing to our inability to make like really concrete progress on this across the profession is, how do the humans get in the state where they can actually do this? And part of the issue with the humans getting in the state where they can do this is this behavior rewarded? Do they have the capabilities? Is it something they're interested in? All of these kinds of questions about the socio-technical bit, or sorry, the socio side of the socio-technical bit. But actually, although human beings are kind of famously unpredictable in various ways, et cetera, et cetera, et cetera, what I see when I talk to teams across the industry, in my current role, I get to talk to teams in very different kinds of companies, from small to large and so on and so forth. But I see, again, I'll come back to this, social definitions of success that fall within kind of one standard deviation of behavior that I'd say all of the panel are familiar with. I don't see a lot of organizations going, we are going to fundamentally reinvent X. Instead, they're saying, can you just make sure this thing keeps going, please? And make it a bit better over time. That'd be nice as well, but keep it going. And from that point of view, I think the organizational mandate to make non-incremental, to make revolutionary changes in our understanding and progress and so on and so forth, it's just not that widespread. Like, the best I've seen is probably Google, but like the second and third, there's a real big drop off, as Bill Hicks used to say.
Do you think that there's a compelling business case to be made that would justify an investment in, I don't know, basically pure science of SRE, so to speak? Because typically in an academic, you have the applied sciences and you have the pure sciences. And it sounds like you're calling for an investment in the pure science side.
Well, as a high modernist, of course, I would do that. But let me just say the one sentence, which is actually most of the time we struggle to get people to care about it in the first place. If that is actually the more fundamental hump, because it turns out, I suppose on average, the teams, startup teams, enterprise teams, et cetera, typically ignore reliability as a concern until it reaches some kind of level, often the level by which it's very difficult to actually do anything about it, except if you'd started earlier, it would be easier, et cetera. So really the fundamental challenge is the social challenge of getting them to care about it. But often the social challenge is related to the economic challenge. I can spend $10 on making this feature and get this money as a result of this feature, or I could spend $10 on increasing a percentage chance that the existing money flow will be retained or optimized in some way. Well, like I'm chasing product market fit. There's a lot of, and that's another unsolved problem, I think. We don't know how, not just how to define reliability, We don't know, except in very narrow contexts, what its value is. That's
Excellent
another.
point.
Yeah, I think to
Excellent
pick
point.
up on
Okay,
what-
Sandhya.
Yeah, to pick up what Niall mentioned, right? At the end of the day, it doesn't matter, it's a startup. Maybe there's a set of 3 people, right, starting to make decisions. And decision makings, for the most part, is still made by humans. And I think that's the social aspect we are talking about it, right? I mean, the way I look at it is like, okay, when a new engineer joins a team or a company or what have you, how do we empower them with the information to get up to speed of being able to make that decision, right? I think this whole onboarding exercise and how do we get to the tenure aspect that Laura was mentioning, right? You may be like 1 week into your job, but what are the tools and like ways you can get that engineer up to speed to have that information accessible to make those decisions, right? That will sustain past that engineer's tenure in the company or what have you. I think that's one aspect of it. We do a poor job, in my opinion, to get engineers up to speed in their new roles. I think that's one thing. The second aspect of it is another new pattern we are noticing is pretty much every company is in the process of this engineering productivity initiatives, right? That's again the tooling gaps we run into, wherein we have 5 different things to do every single thing, and this is just in a team and a company, an organization, and across companies. I think there's a lot of multiple ways of doing things, which makes it harder for us to pick and choose, right? As you're making these decisions, how do you decide based on the data you have? And I think Niall has been re-emphasizing the fact that we make decisions at the spur of the moment with the data we have. And I think what I'm trying to highlight is how do we figure out ways to make that information accessible to the people who are making those decisions, so they're making sound decisions that can sustain. Over to you, Narayan.
Okay, Narayan. Yeah.
So I think, you asked this question, Kurt, about if you thought that it made sense to actually have some sort of parallel activity to examine reliability. And I think you said, I forget if you said academic or scientific, but those have very similar connotations, I think. I think we need to do it. I think it's actually critical. I don't think we know how to do it. I think that, Niall raised a bunch of really critical questions about how you do this kind of work and how you equip teams to do this kind of work and make the space and value it fundamentally, and then connect that to the business value question. And I think all of these things are hard. I don't think that the traditional academic research, externalized sort of approach is going to work for this. This is going to take a very specific style of program chartering, and these are efforts that are going to need to exist in a larger organizational ecosystem that is complicated in a variety of ways, right, and has both short and long-term interests and so forth. But really coming back to what I was saying before, I think the thing that's really important here is that our services are getting too important, right? They're too big, they're used for too much, and they need to work. And if that's true, we need to figure out how to invest.
Awesome. I think that is a fabulous call to action. And we are pretty much out of time at this point. So I want to thank everyone on the panel. I want to encourage all of the audience to chime in on the Slack conversation around these areas. And I would go for Narayan's call to action. I think besides requiring investment from a larger type of organization, I'd really love to see this trans-organizational, to be something that could be done for the profession as a whole, as opposed to just benefiting 1 or 2 small companies that happen to have research arms that could potentially commission something like this. But again, thank you all for participating, and look forward to the ongoing dialogue in the Slack channel.